In this video, let us look at capacitor. 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 What is a capacitor? Capacitor is a device. Capacitor is a device. Capacitor is a device. It's a device that is used. That is used to store charges. To store charges. It's a device that is used to store charges. The charges stored in a capacitor are static between the two plates of a capacitor. This is a capacitor, this is a capacitor. These are the two parallel plates of a capacitor. The capacitor is used to store charges, and since the charges were static in the capacitor, that means the charges are stored in form of what? Potential energy. The charges are stored in form of what? Potential energy, or in form of what? Electrostatic potential energy, because the charges are static. They are stagnant in the world two parallel plate. That is why we say the charges stored in a capacitor are stored in form of what? Electrostatic potential what? Energy. Electrostatic potential energy. Electrostatic potential energy. The charges stored in a capacitor are in form of what? Electrostatic potential energy. If they ask you what kind of what energy is stored in a capacitor, the answer is what? Potential energy. Potential energy is stored in a capacitor. Why? Because the charges stored by a capacitor is static. It is static in the two parallel plate, between the two parallel plate, and that what? Charges are stored in form of what? Potential energy. Don't forget, capacitor is a device that is used to store what? Charges, and those charges are static. They don't move. They are static. That is why, since those charges are static, the charges are stored in form of what? Potential energy. Take note. If you were asked what kind of energy is stored in a capacitor, the answer is potential energy. Or if which of the following is stored in a capacitor, the answer is what? Charges. Or the charges are stored in form of what? Potential energy. Take note of that. Take note of that. Let us move further. What are the factors affecting, or before we go to factors, what is a capacitance? What is capacitance of a capacitor? What is a capacitance? Capacitance of a capacitor. What is a capacitance of a capacitor? The symbol is what? C. Capacitance means C. Capacitance of a capacitor is the ability of a capacitor the ability of a capacitor to store charges. The ability of a capacitor to store charges in form of what? Electrostatic potential energy. In form of electrostatic potential energy. In form of electrostatic potential energy. That is what? Capacitance of a capacitor. The capacitance of a capacitor is the ability of a capacitor to store charges in form of what? Electrostatic potential energy. Then what are the factors? The factors affecting capacitance of a capacitor. Factors affecting, and before I go to the factors affecting capacitance of a capacitor, take note. Capacitor is also used to store DC voltage. Take note, DC voltage. It cannot be used to store what? AC voltage, because alternating current is a current that flows in that flows periodically, that flows in reverse direction. Capacitor cannot store AC. It cannot store AC voltage. It cannot store this one. It cannot store this one. It cannot store AC voltage. It can be used to store DC voltage. Take note. Capacitor is also used to store DC voltage. Take note of that. Then let us move to factors affecting capacitance of a capacitor. Factors affecting capacitance of a capacitor. Factors affecting capacitance of a capacitor. Or before I move to capacitance of a capacitor, take note of this, that the quantity of charge stored by a capacitor, is directly proportional to the potential difference across the two parallel plates, this symbol means parallel, across the two parallel plates. The quantity of charge stored by a capacitor is directly proportional to the potential difference across the two parallel plates. Take note of this. That means we have quantity of charge is directly proportional to our potential difference. Then we have quantity of charge. Change the proportionality sign to a constant. That means you have equal to CV. Quantity of charge equal to what? CV. We have quantity of charge is directly proportional to potential difference across the two parallel plates in the capacitor. The charge stored by capacitor is directly proportional to the potential difference across the capacitor. The charge stored by capacitor is directly proportional to the potential difference across the parallel plate of a capacitor. Then change the proportionality sign. We have quantity of charge equal to CV. That means this C is a constant which is known as what? Capacitance of a capacitor. It's known as capacitance. Capacitance of a capacitor. It's known as capacitance. You can say it's called capacitor. You can say capacitance or capacitance of a capacitor. Capacitance of a capacitor. Capacitance of a capacitor. And the unit is of farad. Farad. It is measured in farad. Capital F. It is measured in farad. From here, if you make C the subject of the formula, we have C equal to what? Q over what? V. Take note of that. We have C equal to what? Q over V. That means note of this. We have capacitance. Take note. Capacitance of a capacitor is inversely proportional to potential difference. Is inversely proportional to what? Potential difference. That means capacitance of a capacitor is inversely proportional to what? Potential difference. That means if capacitance increases, potential difference decreases. Capacitance, if it increases, take note, increases is there in your past question. If capacitance increases, potential difference, that means the voltage potential difference decreases. Take note of that. Decreases. Take note of that. Let us go to factors affecting capacitance of a capacitor. Factors affecting capacitance of a capacitor. Factors affecting capacitance of a capacitor. Affecting C. That means C means what? Capacitance of a capacitor. Factors affecting capacitance of a capacitor. Number one, cross-sectional area of the plate. Cross-sectional area of the two parallel plate. Area of the two parallel plate. That means cross-sectional area. Number two, another one. Number two, we have distance between the two parallel plate. Distance between the two parallel plate. Distance between the two parallel plate. We have distance between the two parallel plate. Number three, we have dielectric material. Dielectric material between the two parallel plate. Between the two parallel plate. Take note. Let us take them one by one. The first one, that means cross-sectional area. Cross-sectional area. That means A. Take note, capacitance of a capacitor is directly proportional to the cross-sectional area of the two parallel plates. Meaning that if capacitance increases, the area of the plate must also what? Increase. If capacitor increases, the area of the two plates must also what? Must also what? Increase. That means as capacitor increases, the what? The two parallel plate must also what? The area of the two parallel plate must also increase. For example, look at these two parallel plates. This one. Look at this one and look at this one. Which one has larger area? This is case 1. This is case 2. Case 2 has what? Larger area. Case 2 has what? Larger area. Large cross-sectional area. That means this one will store more charges than this. This 2 will store more charges than this one, because this one area is what? Larger than this area. Therefore, this one will store more charges than this. Let's go to the second one. Number 2. Yes, ma'am. Number 2. Let's go to number 2. That is distance. I'm sorry for that break in transmission. Let's go to number 2. Distance between two parallel plate. Distance between the two parallel plate. For example, that means capacitance of a capacitor is inversely proportional. This one, inversely proportional to the distance between the two parallel plates. That means capacitance is inversely proportional. Inversely means 1 over. Inversely proportional to the what? Distance between the two parallel plates. That means if capacitance increases, distance between the two parallel plates must what? Decrease. Distance must decrease. If capacitance increases, the distance between the two parallel plates must what? Decrease. That's the meaning. That means if this one increases, this one what? Decreases. If this one what? Decreases, this one will what? Increase. That's the meaning. That means look at this. When I have two parallel plates of the same area, this first parallel plate, I have another case of the same area, but the distance between this one is wide. If you are asked which one will store more charges between these two, which one will store more charges, And I told you, as capacitance increases, distance will decreases. You understand? That means this one, this number one, because the distance is very small. Look at the distance. The distance, this is the distance, is very small. But look at the distance of this one. The distance of this one is very large. The distance between these two plates, look at the distance. This distance is very large. And if you have large distance, that means it will store small charge. But if you have small distance, it will store large charge. That means the capacitance of this one is greater than this, because this one has small distance. That means it will have a larger capacitance. This one has large distance, it will have a small capacitance. Take note of that. Let's move. Dielectric material, the third one. Dielectric material. Dielectric material. If they ask you, is there, what kind of dielectric material do we use between the two parallel plates of a capacitor? We use insulators. Insulators. Insulators, such as paper. We use insulators such as paper as dielectric material. That means when you have two parallel plates, there must be dielectric material. This one, can you see? This is dielectric material, which are insulators. These are insulators. They are dielectric material. That means this one, this case one, has dielectric material, which are what? Insulator. But look at this second case. This one has no dielectric material. This one is what? Air. In this one is what? Air. That means vacuum. In this case, if they ask you which one will store more charges, this case one will store more charges, because this one contains what? Dielectric material. If you have two parallel plates that contain dielectric material, it will store more charges than the one that has what? Air. That is vacuum. That is what? Of free space. This one that has dielectric material will store what? More charges. Take note of that. This one will store more charges. That means two parallel plates that has dielectric material will store more charges. That means this one stores more charges. That means it stores more potential energy than this one. Take note of that. Then let us relate the factors together. That means we have capacitance of a capacitor is directly proportional to area and inversely proportional to distance between the two parallel plates. I gave you this. Therefore, we have capacitance of a capacitor equal to permittivity. Permittivity times what? Area over what? Distance. Take note of this formula. Where E naught is what? Permittivity of dielectric material. Dielectric material. Some people will call it constant of what? Or constant of dielectric material. Some people will call it constant of dielectric material. It's called permittivity of dielectric material or constant of dielectric material. And we know that A is what? Area. A is area or cross-sectional area given in what? Meter square. D is what? Distance between the two parallel plates given in what? In meter. While C is what? Capacitance given in what? Farad. What will now be the unit of permittivity? The unit of permittivity will be what? What will be the unit of permittivity? Don't forget, we have C permittivity. If you make permittivity the subject of the formula, you have permittivity equal to what? CD over what? A. Therefore, the unit of permittivity will be what? Farad per what? Meter. This one will be what? Farad per meter. The unit is what? Farad per meter, because unit of capacitance is farad, unit of distance is what? Meter, while the unit of area is meter square. Meter cancel 1 meter, then we have farad per meter. The unit of permittivity is what? Farad per meter. Let us go to connections. Connection of capacitor, which is the last one. Connection of capacitor. Connection of capacitor. Capacitor. Capacitors can be connected in number one, parallel. Parallel connection of capacitor. It can also be connected in parallel, and it can also be connected in what? Series. Series connection. Series connection. And let us look at the parallel connection of capacitor. Parallel connection of capacitor. When capacitors are connected in parallel, that means when you have this, let me assume you have 3 capacitors connected in parallel. They have the same potential difference across them, but they don't have the same charges. They don't store the same charges. When you have 3 capacitors connected, or when you have capacitor connected, it can be more than 3, it can be 2, it can be 3, it can be 4. Let me call this one C1, capacitance of this one, capacitance of this one C2, capacitance of this one C3. When you have capacitors connected in parallel, they have the same potential difference. That means the same volt, which is the same thing as total volt, which is the same to the total volt of the circuit. Total volt is the same as the total volt. If the total volt, for example, is 25 volt, that means the volt of C3 will be also 25. The volt of C2 will be also 25. The volt of potential difference of C1 will be also 25. And the total volt will be also 25. But take note of this. They don't have the same current. Number two, when they are connected in parallel, they don't store the same charges. They don't have or store or have the same charge. When they are connected in parallel, they don't have the same charges. Take note. When capacitors are connected in parallel, they don't have the same charges. Then for you to calculate the effective capacitance of capacitor in parallel, the effective total capacitance of capacitor in parallel, total capacitance of capacitor in parallel, total capacitance of capacitor in parallel. That means you have C1 plus C2 plus C3. For example, when you have this, let me assume you have 3 capacitors in parallel. Each of capacitance, let me say this one is 2 microfarad, this one is 3 microfarad, this one is 4 microfarad. If the question says calculate the effective or the total or the net capacitance of this capacitor, the answer will be 2 plus 3 plus 4, which is equal to 9 microfarad. And take note, for parallel connection of capacitor, the total capacitance is greater than individual capacitance. What do I mean? Look at this. What is the total capacitance? 9 is greater than individual in parallel. Take note of that. It's different from that of resistor. The parallel connection of capacitance is series connection of resistor. The parallel connection of capacitance is series connection of resistor. Take note. It's just like that. They are almost the same thing in their calculation. Take note of that. Let's go to series connection of series connection of capacitor, series connection of capacitor, series connection of capacitor, series connection of capacitor. Take note, when capacitors are connected in series, they store or they have the same charges. When capacitors are connected in series, they have the same charges. They have or store the same charges. They store or have the same charges, which is equal to the total charge. They store the same charges, which is equal to the total charge. Let me assume this one store 30 coulomb. The charge that will be in this one will also be 30 coulomb. The charge in this one will be also 30 coulomb. They store the same charge. Capacitors store the same charge when in series, but they don't have the same potential difference. They don't have the same potential difference. That means they don't have the same volt or the same voltage. They don't have the same voltage. And the total voltage, take note, the total potential difference or the total voltage is the sum of voltage in C1 plus voltage in C2 plus voltage in C3 plus voltage in C3. That is the total volt. That means the total volt, you have to add volt in each of them to get the total volt. They don't have the same potential difference. But the total potential difference is the sum of their potential difference. The sum. Take note. When they are in series, they don't have the same potential difference. Then for you to calculate the effective, the total capacitance of capacitor in series, total capacitance of capacitor in series. The formula is 1 over C1 equal to 1 over C total rather. The reciprocal of the total capacitance is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Like the way you calculated total resistance of parallel connection of resistors. The same thing. The series connection of capacitor is like parallel connection of resistor. Take note of that. For example, when you have 3 resistors in series. Let me assume this one is 2 microfarad, 3 microfarad, and 4 microfarad. If the question says calculate the total capacitance or the net capacitance, I will say 1 over CT equal to 1 over 2 plus 1 over 2 plus 1 over 4. Therefore, 1 over CT equal to LCM is 4. 3 in 4, 2. 2 times 1, 2. Plus 2 in 4, 2. 2 times 1, 2. Plus 4 in 4, 1. 1 times 1. You have 1 over CT equal to You have 5 over 4. Then from here you have CT equal to 4 over 5. 4 over 5. Therefore, CT 4 over 5 is 0.8 microfarad. Take note, the total capacitance of capacitor in series is smaller compared to individual value of ohm. That means the total capacitance of capacitor in series is less than individual value of individual capacitance, smaller than individual capacitance. is smaller compared to individual. Can you see the total one is for what series is 0.8. Can you see it's smaller than individual, it's smaller than 2, smaller than 3, smaller than 4. Take note. Let's go to cases. Cases under this one, under series connection. Cases. Case 1. Case 1. When you have two capacitors connected in series, two capacitors connected in series, C1, C2. To calculate the effective capacitance of this capacitor, instead of using 1 over Ct equal to 1 over C1 plus 1 over C2, you can use Ct equal to what? You can use Ct equal to what? C1 times C2 all over what? C1 plus C2. For example, let me assume this one is 2 microfarad, this one is 3 microfarad. Instead of you using 1 over Ct equal to 1 over 2 plus 1 over 3, to have 1 over Ct equal to LCM is what? 6. 2 in 6, 3 times 1. 3 in 2, 6. 2. 2 times 1. You have 1 over Ct equal to 5 over 6. Therefore, Ct equal to what? 6 over what? 5 microfarad. Instead of using this formula, you can apply this second one. That means Ct will be equal to C1 is what? 2 times C2 is what? 3 all over what? 2 plus 3, which is Ct equal to what? 6 over 5 microfarad. That is case 1. Let's go to case 2. Case 2. When you have two or more capacitors connected in series, this one could be two or more capacitors connected in series. If they have the same value of farad, for example, let me say they have the same value of farad, the same value of what? Capacitance. If they have the same value of capacitance, when you have two or more two or more capacitance, or capacitor rather, two or more capacitor, two or more, it could be 2, it could be 3, it could be 4, but the condition is that they must have the same value. Instead of you using 1 over Ct equal to 1 over C1 plus 1 over C2 plus 1 over C3, you can apply this formula, Ct equal to what? C over N, where N equal to number of capacitor. You can try it using this one on your own. You can try it. You see that you get the same answer. Let me use this one. That means you have Ct equal to the capacitance. Since they have the same value, take one of them, 2 all over. Since they have the same value, take one of them as your C. Then N is your number of capacitor. How many capacitor do we have? 1, 2, 3. That means 2 over 3. Therefore, Ct equal to what? 2 over 3 microfarad. You can try it by using this one. You see that you get 2 over 3 microfarad. Third case, when you have 3 capacitors, this one is also 3 capacitors in series. If they don't have the same value of ohms, let me assume they don't. This one is 3 microfarad. This one is for 2 microfarad. This one is 4 microfarad. If they don't have the same value of ohms and they are 3, instead of you using 1 over Ct equal to 1 over C1 plus 1 over C2 plus 1 over C3, you can use this formula. Ct equal to C1, C2, C3 over C1, C2, that means C1, C2 plus C2, C3, C2, C3 in bracket plus, then take C1, C3, C1, C3. Take note. That means 2 of them must appear 2 times. That means C1, C2 plus C2, C3 plus C1, C3. That's that. You can use the 2 formula to solve this question. You see that you get the same value. Let's move on. Right. Relative permittivity. which is a relative permittivity. Relative permittivity of a capacitor is calculated as what? Relative permittivity is what? Permittivity of medium all over permittivity of free space. Relative permittivity is the ratio. Relative permittivity is the ratio. Relative permittivity is the ratio. Relative permittivity is the ratio of permittivity of medium to permittivity of free space, where ER is what? Relative permittivity, while EM is what? Permittivity of medium, while E naught is what? Permittivity of free space or vacuum, Take note of that. Let's go to the last one in this video. The last one for today. Let's go. The last one for today, which is what? Work done by a capacitor. The work done by a capacitor, or energy stored in a capacitor. Right. Work done by a capacitor or energy stored in a capacitor. Don't forget, energy stored in a capacitor is for potential energy. That means the charge is stored in form of a potential energy. Energy stored in a capacitor. Take note. The energy stored in a capacitor, the energy stored in a capacitor or the work done by a capacitor is given as what? Half QV. Take note of this. And don't forget, what is Q? Q is what? Capacitance times what? Potential difference. Charge is what? Capacitance times potential. When you remember CV, curriculum vitae, CV, that means charge equal to what? CV. And when you know that Q is what? CV, change this Q to CV, and we have energy stored in a capacitor is what? Half. This Q change it to what? CV times what? This V. You have energy stored in a capacitor is what? Half CV squared. Half what? CV squared. From here, if you make V the subject of a formula, from here, take note of this formula also. If you make V the subject of a formula, we have, since V equal to what? Q over C. Change V in this word, in this formula, and we have E equal to what? Half C. This V will be changed to what? Q over C. Everything raised to power what? 2. Then you have energy equal to what? Half C times what? Q squared over what? C squared. C cancel what? 1C. You have E, energy stored, equal to what? Half Q squared over what? C. Take note of these three formula. These are the formula for energy stored in a capacitor. In the next video, we are going to solve some questions from your past question. Thank you. I remain myself, Jama.